In this video, we're going to learn how to model an IsoGrid structure in Fusion 360 so that way we can change a single parameter and have the design update, so stay tuned. Hey everyone, this is Matt with Learn Everything About Design, and in this video, we're going to model an IsoGrid in Fusion 360. Now, this question came up on the Discord channel for this YouTube channel, and it was interesting that I couldn't find any resources or videos on people modeling a true IsoGrid in Fusion. So what we're going to do is we're going to cover a single approach for this in Fusion, and we're going to talk about some of the parameters that we might want to drive and ways in which we can use this in our models. Now, with anything in CAD, there are multiple ways to do this. So if you have a different approach that you like to use and have used, please leave it in the comments, and that way other people can decide what works best for them. So before we get started, let's first talk about this IsoGrid structure. Let's talk about some of the different configurations that we can have and essentially what that means for us downstream. So what we see here on the screen is an IsoGrid structure. And essentially what we're looking at is a pattern of 6 triangles. And this is going to be a lightweighting technique that's used in aerospace to make extremely strong and rigid parts, but minimize the amount of mass that these parts have. So generally, these will have pretty tight tolerances and restrictions on the thicknesses on the base material. They'll generally be really thin, and the thickness of these ribs. We're not going to get that deep into this topic. What we are going to do is talk about ways in which we can set up our parameters to drive and adjust these. So we'll get to see that at the very end. So let's get started first with a brand new untitled document. We are going to be taking a look at a metric document. This could be in inches as well if you want, but for us it's going to be metric. And we're going to start by driving a couple of parameters. So we're going to go into change parameters, and we want to start by creating a few parameters. Now over here on the left side of the screen, what you see is exactly what we're going to begin modeling. And there are a couple of different dimensions that we're going to use to drive the shape. And we're going to also gather some dimensions from those original driven values, so that way we can pattern this later. Now, we're going to be drawing the outside of this triangle for the IsoGrid, and we're going to use the shell tool to get the walls and the thin walls or the thicknesses that we need. So that way we have a very simple sketch. We don't have to do anything very complex. So the first thing that we need to understand is going to be that this specific IsoGrid, we're going to be using a 60-degree angle, and we're going to be assuming the hypotenuse of this as if it were a 90-degree right triangle. We're going to be assuming that value is going to be needed for the pattern of our height. So let's get started first by driving the width of this triangle. So we need to make sure that we name this something meaningful. And for me, let's go ahead and call this just something simple like width. I'm going to set this to 75 millimeters now, and this is essentially going to drive everything else. We then want to gather some information on, again, that hypotenuse value. It's not truly the hypotenuse in the case of our triangle, but this is the value that we're going to be using for the overall height of our patterns. Now, this value comes from the fact that our width value is actually derived from this hypotenuse value. However, to make sure that our patterns are fairly evenly spaced, I'm going to be doing this in the reverse. So this value, this hypotenuse value, is going to be equal to our width, and this is divided by cosine, and we're going to put in brackets, 30 DEG for degrees. So if you want to drive it the other way, basically what you would do is you would find or give the hypotenuse value, and then this width value would be essentially cosine 30 times that value. And we can put those in here just so you can see them. So I'm going to put ALT for alternate hypotenuse. And we're going to go ahead, let's just drive that at 100 millimeters. Actually, let's drive it at 86 millimeters to make it relatively close. And then if we want to find the width, I'm going to go ahead and type in ALT width, and this is going to be our alternate hypotenuse times cosine of 30 degrees. So you can see that they're relatively close, 74.4 rounded to 75. This is 86 instead of 86.603, but you could drive them either way you wanted to. I'm driving it based on the width. I want a nice round value there. You could drive it based on that hypotenuse value, which 2 times that is going to be the overall height. So let's go ahead and I'm just going to delete those because I don't need them. I also want to drive the width of the rib. So I'm going to call this rib width. And I'm going to set this equal to 15 millimeters. Downstream, we're going to actually use that in our shell dialog, but we're going to divide it by 2 because we're essentially making a half or a portion of that pattern. These are really the only values that we need. However, I'm going to go ahead and create a height value, and this is going to be our hypotenuse times 2. Remember that hypotenuse value is essentially one leg of that triangle, and we need 2 of those to get the overall height of this shape. That way we're going to be using this height value for our height set or our spacing for the height of our pattern. So once again, these are really the only values that we need. We could add as many different parameters that we want, but those are the basics that we need. Now let's go ahead and dive into a sketch. I'm just going to select the top plane. And I don't really need to sketch that much. I could just sketch a single triangle. I am going to go ahead and add a reference line here. I'm going to hit escape. I'm going to make that reference line horizontal. I'm going to hit escape again. And also make it construction, which you can do with X on the keyboard. Now the main reason that I wanted that there is so we can see where some of these numbers come from. And if you want to, you can go ahead and finish this out. So I'm going to go ahead and just draw a triangle here. I'm going to draw one here. And then we want to use our constraints like equal to make sure each of these is going to be equal. And the rest of it will fall in line. So if I start to drag this out, you can see everything sort of grows equally, which is what we want. I'm going to use D on the keyboard and make sure that this is 60 degrees because we made the other 3 triangle, or the other 2 triangles, I should say. That value is going to be fixed based on the fact that we made everything equal. We've got a horizontal construction line right at the midpoint, which is going to drive the perpendicular location of that. So again, that's not really needed. Now the width value that we want is to go from this line to this line, and we're going to set this as our width. It should be 75 millimeters. Now you'll notice when I do this, one of these doesn't really come in line. I'm going to hit escape on the keyboard. And you can see that this one is sort of free to float about. Let's just make sure that these are actually equal, and then that'll make sure that it's nice and fixed. Again, D on the keyboard for dimension. I want to just validate the length of this line. It's going to be driven, but what we should see if we go to modify and change parameters, 86.603 should equal our hypotenuse. And the reason that that's important, again, is because we want to know the overall height of this distance here. Again, this is going to be a driven value, but if we go back to modify and change parameters, it should be 173.205 and everything's there. So once again, we're driving this off of one single dimension, that's 75 millimeters, and we really only need this single triangle. So we're going to exit the sketch, E to extrude, and I'm just going to make this 25 millimeters tall. So now what we have is one piece of the puzzle. And I'm going to go into my shell tool. I'm going to select the top and the bottom faces. And for the shell thickness, what I'm going to do is start to type in rib width divided by 2. Now, again, the main reason that we are dividing that by 2 is because the width that we're actually driving is going to be from this edge to another edge on the other side. So that's why we're dividing it by 2. You could build that into your parameters if you want, but I think it's easier for us to control that in the parameters dialog as the width, and then come back and just use it as a half in the shell dialog. We want to do one more thing before we start to pattern. I'm going to use C for my circle tool. I'm going to just put a circle at each corner of this triangle. I'm going to make them all equal. And then I am going to use D on the keyboard to give this a dimension. I'm going to say 20 millimeters. This could be another parameter, of course. And then E to extrude. We'll take each of these pieces and we'll go through all. Now, it's important that we use through all here because if we decide to go back and make this taller or smaller, we want to make sure everything updates. So before we pattern anything, it's also important that you add any fillets that you want on the inside here. You can drive these based on a parameter if you want, based on things like the thickness. I'm just going to manually enter it for this example here. Next, we're going to go to our pattern. We're going to do a circular pattern of this body. Because we did this about the origin, we can use the z-axis. And then we're just going to add a couple of these so that we have 6. And then we're going to box select them all and combine them together. So this is one piece of our puzzle. This is one section of our IsoGrid. We're going to copy this by going to our bodies folder, Control C and Control V. I'm going to move it up and out of the way. And then we're going to use the Modify and Align tool. Now the Modify Align tool will allow us to select a specific point. This is going to be the center point on this face. You might need to flip the orientation. And then we can use Combine, join these two together. And now we've got two sections of our IsoGrid. Now the main reason we did this is because this is needed for us to pattern this effectively. So if we go into our rectangular pattern, select this body, we select our axis as X, and we begin to pull this out and begin to pull this down. What we want to do is use the distribution type as spacing. And for the distribution distance, what we're going to be doing is our width. Now remember, the width is for that one section of triangle, so we're going to multiply that by 2. And then for the height, remember we actually calculated that height value, so we don't need to multiply the height by 2. But now that we have this IsoGrid, I can add as many as I want here by just simply adding them to this pattern, and then we can join them all together. Now here's where the parametric nature of this gets a little bit tricky. Everything we've done so far allows us to update those parameters. However, if we combine all these bodies together, it's going to get tricky if we go back to the pattern and we add more because they won't be included in that combine. So there are some limitations to how well this is going to work. But let's do a test before we get too much further. If I say change the rib width, instead of 15, I only want it to be 12. That's going to change the rib width on all of these instances. So if we zoom in and let's say we make this 8, that means each side of this is going to be 4. Now you can see at some point in time, you're going to get to a position where it fails. Now it failed because of the fillet radius value was too large. Now the fillet radius value being too large has to do with the fact that the hole size that we have is 20 millimeters, and now the hole size is cutting through everything. So if you want to have a fully parametric model that you can update, then all of the values, not just the rib width and the width of this whole section, but the fillet, the diameter of the hole, all these different things have to be based on some sort of logic between each other. But this does give us some flexibility. We can go up and down for this thickness. We should be able to increase or decrease this value and have all the patterns update. So if we wanted to go all the way to 100, for example, that value is driving the pattern distance. But remember, we also copied, moved, and we used the functionality to use align and put those together. So everything should be able to update pretty easily. I'm going to put it back to 75 and say OK. And then I'm going to use combine and put all of these together. So let's go ahead and we'll select this one and then maybe box select the rest of them, join them all together. And now we should have a single solid body, which brings us to our next point. What do we do with this? Well, applying an IsoGrid to a part can be very tricky. So generally, you would model the size of each of these cells based on whatever your area you're trying to fill. But let's say that it's not quite that simple. Let's just come up with some sort of shape that we want to use this for. I'm going to go ahead and just start drawing a shape that's sort of irregular. I'm not going to give it any dimensions, but I'm just going to show you how this process can work. And we'll take a look at this shape. So if I had this body, this is the shape that I want to have the IsoGrid in. I'm going to go ahead and extrude this. So I'm going to extrude it up. Remember we had, I think it was 20 millimeters. So if we look at this from the side, I'm going to make sure that I don't go any higher than that. And so then I want to also go another direction. So we're going to say 2 sides, and for the other direction, we're just going to go down 5 millimeters, and we're going to set this up as a new body. So this new body is going to be a solid body, and we want to remove the IsoGrid from a certain portion of it. So the way that I generally would approach this, there's one of 2 methods that I would use. One is to create a sketch on the top face, and I'm going to use offset. And I'm going to offset this inward the distance I want for the wall. So this is going to be negative rib width. That's that parameter that we used for how wide we wanted those ribs to be. And then I could use this to extrude out the area where I wanted the IsoGrid. So for example, I'm going to extrude this minus 20 millimeters. Again, you could use all sorts of parameters for this. I'm going to cut it away from this object. By default, Fusion will only cut away from the visible objects. Downstream, if you go to rebuild this and other objects are visible, then it can be tricky. But I then want to reuse that same sketch, and I'm going to go minus 20 millimeters again, or you could go down to a specific face, and I'm going to call this a new body. Now, the reason I want to do this is because I can then use combine with the intersect option, and I'm going to do the target body as this new extrude. The tool body will be my IsoGrid. And I'm going to actually say keep tools just in case I want to use the IsoGrid again for something else. But now what we're left with is this body here, which should fit perfectly inside of that original. So now we can use combine, select the outside of the original. We're going to select the IsoGrid, and we'll put these together as one. I'm going to turn off that keep tools. And now we've got this IsoGrid applied to the inside of our part. Now, this was not anything that I measured, so there are areas that are potentially problematic, like this tiny hole right here. So what I would generally do is I'm going to hold down the left mouse button, select that face, and just hit delete. And Fusion's pretty good at patching these holes. I can do the same thing over here, hit delete, just allow it to patch that. And on the corner here, you can see we're kind of rolling over there. Just hit delete and let it patch that as well. And you can always come back and add more details if you need, but anywhere that there is a potential problem, you can go in and select those faces and just use the delete tool. Now, you could spend the time to lay out your IsoGrid as just a sketch inside of a specific part, but remember what we did here was we based this all on our parameters. So if I come back and full disclosure, I haven't tested this yet, so we'll see together if this works. If I wanted it to be a little bit thinner, let's say 12 millimeters, theoretically, it should update the original triangle, it should update the original IsoGrid, and it should update everything else that we see here. We can also go into other parameters here. So for example, we've got an extrude, we've got a shell feature, we've got some original sketches. If there are any things that we didn't actually drive as a specific feature. So let's say the hole. Let's go ahead and let's say OK here. And let's right click on this and show the dimensions. Let's say that we wanted to make that hole smaller. Again, because everything is based on those original parameters, we should be able to update and modify these. You'll notice that it did come up with an error for the delete face, which is that's totally possible because changing the diameter of this, increasing or decreasing that, is going to have an effect on which holes we see here. So you can see making it smaller, that hole isn't even there anymore, and it does change these holes on the side. So there are plenty of ways that we can use this to our advantage, and just basically by starting by drawing a single triangle. Let's go ahead and just do a quick recap to make sure we understand the process that we went through. So we laid out the original parameters, and we laid out inside of those parameters, we laid out really a single dimension that we were driving, that 75 millimeter dimension. Everything else, these were references. We used this, which was what I was calling the hypotenuse. If we were looking at a 90-degree right triangle, that value times 2 gave us the height of our pattern. So everything is driven off that 75 millimeters, and that gives us the width that we need for our pattern. It gives us the height, which means as we begin building this IsoGrid structure, everything should update properly. The second copies, all of the patterns, all the features, and it gives us the flexibility to make changes and update these. So let's try this one more time. Probably pushing my luck here, but let's make this 75, let's make this 80 millimeters, which is going to increase the size of each of those triangles just a little bit, and you can see that it updates the body just fine. If we go all the way up to 100 millimeters, again, we're reducing the amount that we have, we're increasing those spaces, but once again, it is fully parametric. It allows us to make those updates and those changes. But remember, not everything is going to update properly. Things like delete face that are based on manual face selections, those are going to be more problematic. But overall, I think the process is relatively simple. You can drive it with as many parameters as you want. And in this case, we just used one 75 millimeters, and that was really the basis for everything else. At this point, if you have any questions on this, let me know. If you happen to have another method that you use for designing these IsoGrid structures, I'd love to hear it, so please leave a comment. And if you like this content or you want to see anything else, please let me know that as well. As always, thanks for watching, and we'll see you next time.